So guys, today I have a very interesting topic for you. I'll be teaching you about electricity. Right? Do you guys know what electricity is?
Yes.
Have you ever seen electricity before?
How can
No,
you see
just used it.
Okay. So guys, I'll be teaching you basically about resistors in parallel, right? So basically we see this every day, right? We use it in our everyday lives where we have probably a 4-room house whereby we have a kitchen, we have a bathroom, we have a lounge, and a bedroom, right? So that's an example of parallel connection, right? Whereby there are many pathways where the current can flow or the energy can flow, right? So that's basically a parallel connection. So a parallel connection is basically more than one pathway. Are you guys with me?
Yes.
Okay, so what happens is we've seen this, but we did not know, probably or hopefully, even prayerfully, after this lesson, you guys will understand or look at the kitchen or bathroom in a different way, right?
Yes.
So what happens is, right, we have different formulas. Because we are dealing with physics, we have formulas, we have definitions, etc., right? Substitutions and answers. So what happens is, first things first, right? We need to familiarize ourselves with this formula, right? So guys, in parallel connections, right, in physics, which is electricity or electric circuits, we have this formula. This formula represents Ohm's law, right? You guys are probably wondering what Ohm's law is, right? So Ohm's law states that at a constant temperature, right, the potential difference across a conductor is directly proportional to to the what? Do you know it? Do you guys know it?
No.
It's in your exam guideline, guys. It's in your yes, to the resistor at constant temperature. So guys, the minute you guys have a formula like this, right, or there's a direct proportion or proportion, right, inverse or direct proportion, what you do is, or what you need to bear in mind is that there must be a constant variable, right? So when you are defining this, right, what you need to know is the temperature is constant. There are two things that we are comparing: the potential difference and the current, right, at constant temperature. Are you guys with me?
Yes.
Okay, moving along. So this R represents resistance, right? And this V represents voltage. This I represents current, right?
Yes.
Now, this resistance is measured in, or the SI units for resistance are ohms. You guys probably learned this in grade 9. You were introduced to this in grade 9.
Yes.
I know, because I was the one who taught you that. So, the voltage, right? It's measured, the SI units are measured in V, volts, right?
Yes.
Then, for current, it's amps or amperes, right?
Yes.
Guys, you don't write the full name. You just write the symbol. That's enough for you to score marks. Are you guys with me?
Yes.
Okay. So you're probably wondering what resistance is, right? Are you guys wondering that? Yes, no?
Yes.
No, yes?
Yes.
Which is which?
Yes.
Yes. So basically, I would say resistance is having to resist something or oppose something, right? Having to oppose something. So, for example, if Musa wants Akona or Aya, right? Aya will resist Musa.
Yes.
So there is resistance between them, right? That's opposing whatever Musa comes with to Aya or Akona, right?
Yes.
Do you guys understand?
Yes.
Okay. So basically resistance is whereby there's a what you call a resistor in a circuit, right? It resists the flow of charge, or it resists the energy, flow of energy, right? Do you guys agree with me? In a conductor, there's a flow of energy. For us to see that the light bulb is lighting properly, there must be flow of energy from the source, which is the battery, right?
Yes.
So this is there to resist that energy, right? So resistors actually help us in many ways, because you guys see probably a light fuses, right? Because there's a high current or high flow of energy. So if there's no resistance or resistor, right, the bulb is most likely to fuse, right? Or even transformers, they can even blast because there's little resistance. Are you guys with me?
Yes.
Okay. Moving along, we have the voltage. So voltage is the measure of the potential energy or flow of charge, right? Between 2 points in a circuit, right? So it has this formula, right? So basically voltage, what you see in a battery, you guys have phones. Are you able to see your batteries? Back then we were able to see our batteries, right? Are you guys aware of that, or are you guys young? Okay. So what happened was, back then, when we had phones, smartphones, right? We guys were able to see our batteries, right, at the back of our phones. So what happened was, when you check the battery, you'd usually see something, a number, right? Probably 12 with V. If you guys noticed, I was too curious when growing up, right? I was too curious, but I wanted to know what the 12 stands for and whatever. But that is actually the voltage, right? Or it's called the EMF. So what happens is, right? So what happens is, yes?
What is the definition of EMF?
EMF is the maximum energy required. But you do have your exam guidelines, guys, if I'm not so accurate, right? So please follow whatever your exam guidelines says, right? So it's the maximum energy supplied by a battery per unit charge, basically, right? So it supplies maximum energy across the circuit at a certain period of time. That's EMF. Are you guys with me?
Yes.
Okay. So this is the voltage, right? Now we are busy with current. Current is actually the measure of the amount of flow of charge passing through a fixed point, right?
Yes.
So it's basically the flow of charge at a certain point. That's current. So now guys, as I said, I was speaking about or talking about resistors in parallel, right?
Yes.
Now there are formulas for us to calculate these, right? Of which we have I total is equal to I1 plus I2, right? Then we have R parallel is equal to product over sum. And then we have voltage parallel is equal to V1 is equal to V2. What you can bear in mind again is, in this or in a parallel connection, your V parallel is, as I was saying, yeah, that this, your V parallel or your voltage that is parallel in a parallel connection, right? Your V parallel is equal to V1 equal to V2. Meaning, in this, how do we know that it is a parallel connection? Because it has different or more than one pathway. I have a question, yes?
Yes, I have a question. Yes, so say you were saying that the voltage in a parallel connection is equal. What about the current?
I will get there. Just because I started with voltage I will explain the total current and I will explain the total resistance. I will answer you. So thank you for the question. So what happens is, because this there's a flow, right? There's a flow of current, yeah?
Yes.
But when it gets there, the current splits, or there is more than one pathway, right? Therefore, we are aware that this is a parallel connection. Do you guys understand?
Yes.
Is there any question? Not yet, no? Yes. So what happens is, no? Meaning the voltage that is parallel, right? Meaning this voltage will be equal to this, and this. This is resistor 1, this is resistor 2, this is resistor 3. Meaning this voltage will be equal to this, and this voltage will be equal to 24, and this voltage will be equal to 24. Do you guys understand this formula?
Yes.
Are you sure?
I have another question about the voltage.
Yes.
Yes. So say when switch is open, you know in second switch on us, it means to vice the switch yavulwa in the back. So xa ivuliwe i-switch noma xa ivaliwe ilo EMF izofaka voltage.
There's a difference between voltage and EMF, right? EMF is the maximum energy that a battery can supply, right? Then for the voltage can change, right? But for a parallel circuit, the voltage does not change. So if the switch is open, the EMF will be equal to the EMF, right? If it was 24 and the switch is open now, even when it's closed, it will still be 24. The EMF does not change because that's the maximum amount. For example, if you do know your power, or the maximum power that you can push a door or something, right? That's the maximum power that you can offer, right? For example, if you're asked,
Okay.
so as I was saying, if you do offer 24 volts, that's the maximum amount, regardless of whether you are sleeping or awake, right? Meaning regardless whether the switch is closed or open, that's the maximum you can offer.
Yes.
Are you guys with me?
Yes.
Now the voltage changes because once the switch is open, right? The voltmeter can register a different voltage. A voltmeter is, I would say it's a tool, right? Used to calculate the voltage, right?
Yes.
So, yeah. Did I answer your question?
Yes.
Okay. So now we have the resistance, which is parallel. Now for this, we have two formulas, right? So it's resistor parallel, right? Or parallel resistor, right? Is equal to product over sum. This only applies for two resistors. I'm not sure whether you understand. So this formula only applies for this case, right? Or this question, whereby you have only two resistors. Only two, right? As for this one, this formula won't apply because you have three resistors. Do you guys understand?
Yes.
So you only use this formula if you have two resistors. What do you do if you don't have two resistors? You have this formula. 1 over R parallel is equal to 1 over R1 plus 1 over R2, right?
Yes.
So here what you do is you basically substitute each and every value that you get, then you take the reciprocal. Are you guys familiar with the reciprocal?
No, sir.
Which is, you raise it to -1, basically. Then you get your resistor that's parallel, right? So, I'm not sure whether you guys follow or not, but hopefully once we do the example, you will follow, or you will all be on board. So we have I, which is total current, right?
Yes.
Total current is equal to I1 plus I2, right? Meaning, if this splits, right? If this current here, it has probably 7, right? Now, the current flows, it flows, then it splits here, right? It started with 7, it must end with 7, but the current split, right, into different pathways. So what happens is, these different pathways will register a different current. Are you guys with me? Yes. From there, once they join forces here again, or they join here, they must register 7 amperes. Are you guys with me? Yes. Okay, so moving along to the question, right? So, I have the questions with me here. First question, calculate the current flowing through each resistor. That's question number 1, right? Due to space, I wrote the questions here. So it says calculate the current flowing through each resistor. Meaning each resistor is, this is a resistor, this is also a resistor. Do you guys understand? Yes. So we have 2 pathways basically, right? Yes. Now, what happens is, right? Oh, another thing, don't get caught, guys. There's this and this is the same thing. This represents a resistor and this represents a resistor. So in the exam or in the test, when they give you this, don't call me and ask me, sir, I don't see a resistor. There's the resistor in front of you. You guys understand? Yes. Okay. So now, we are asked to calculate the resistance in each resistor, right? So it will be R is equal to V over I. Don't forget that formula, which is Ohm's law, right? Because we have one, right? When you have one resistor that you're calculating, or resistance that you're calculating, you use Ohm's law. Start with Ohm's law, right? Now we have Ohm's law, which is R1 there, right? We are asked to calculate the current, which is I1 again, right? Then V1. Okay. Now, what did we say about the voltage in a parallel connection? Always the same, right? Meaning, if the EMF or this battery has 12 volts, this will also have 12 volts. This will also have 12 volts, right? Yes. Now, do you guys understand? Yes. Now, this is equal to 12 volts. Now, there's already a reading there for the resistance, right? Which is R, right? Yes. So that's 4 ohms. Meaning you can just substitute because the only unknown is I. Are you guys with me? Yes. Okay. Now, it's 4 is equal to 12 over I. Then, another thing, guys, I almost forgot. Do you know what a triangle is? Or the triangle rule, or triangle method? You probably don't know it. So, this is V, R, I, right? So, you have R, V, I, right? So, what I usually do is, I cover the R, right? When I cover the R, I know that I have V over I. So, this is a divide, right? Now, if I'm asked to calculate the voltage, I cover the voltage, I'm left with R, I, right? So it will be R multiplied. Do you guys understand? Yes. Then, if I have I, I'll have V over R, right? Yes. Now, this is I. There's a catch. There's a catch. I is equal to 2 ohms. Current is equal to 2 ohms. Units. Clue. Clue. A net. Okay. 2 amperes. So guys, the minute you get or you write your SI units wrong, your final answer is wrong. So you will get caught. Just be careful. Number 2. Calculate the total resistance, right? So it will be R is equal to V over I, right? So the total resistance revolves around calculating the total voltage of which you already have it, right? Which is 12, right? Then you have I. But now you know that you have two pathways, right? You have two pathways. So these two pathways, you know, you started with something and you ended with something, right?
Yes.
You do know how to calculate the total current, right? Which is I tot is equal to I1 plus I2, right? So I1 in this case will be this. It's 3, right? Plus 2, which will give you 5. Ne? Very good. Then that will be 5. What's your final answer? 12 over 5. It's 2,4. That's your total resistance. You guys understand?
Yes.
Now, last question. Calculate how much current is delivered from the battery. Basically, they're asking you to calculate whatever is delivered by the battery is the maximum. So it's the total, right? Basically, they're asking us to calculate I total, of which you already did it, right? There is it, which is 5, no? Okay. This, I would like you guys to do this as homework. I would like you guys to do this as homework or classwork, because I just want to test your knowledge. So please do it as a classwork actually. Change of plans, because I do have homework for you. Please do it as a classwork. Yes. Can you guys see? You're fine.
You can give us a homework.
Homework in it. Okay, it's fine. I'll just give you 2 questions for homework. So basically, guys, what I need you guys to know, okay, I'll just give you the steps, then you work it out. Then I'll give you the memo tomorrow, or we'll do the corrections together tomorrow, right? So here, first question, calculate the current flowing through each resistor. R1 equal to V1 over I1, right?
Yes.
Then R2 is equal to V2 over I2, right?
Yes.
Then R3 is equal to V3 over I3, right?
Yes.
Next time I won't be so lenient, just because we got physical sciences last period and it's a Friday, right? So I'll just be lenient. Friday, right? Okay, so now calculate the total resistance in the current, right? So calculating the total resistance is also R V over I. That's Ohm's law, right? But now you need to know, because you're calculating the total resistance, you need to know the total voltage and the total current. Are you guys with me? Yes. So from there, because you got the total current, you can just write it there, or you can do it again. I1 plus I2 plus I3. Right?
Yes.
Then, do you guys like fruit? Or are there any questions? Two?
No.
Are you guys clear? Do you guys understand? Can I test your knowledge? No, not yet. Not yet. But you guys do understand. Okay, so guys, do you like fruit? Fruit. What type? It depends on which fruit you like. Banana, ne? Who likes bananas? Okay, 1, 2. Okay, apples. Okay, 2 again. Orange. You don't like fruit? Pear. Then, banana. Everything, you food killer. Okay, So guys, I have fruit for you today, right? I knew that you guys would want some fruit, just as a form of reward, right? And guys, yeah, I know, okay? So, I have this fruit for you today. I have this fruit for you today. So this is your banana. This is your whatever. Right? This is your apple. This is your apple. This is your pear. And this is your banana. Guys, this is actually fruitful. Think about it. It's actually fruitful. Why? Because I'm testing your knowledge, right? So the minute I test your knowledge, right, it's fruitful for your brain. So there's a deeper meaning into it. Do you guys get me? Yeah. Okay. So guys, thank you. Please do the questions, and those are the questions I will post them on the group. And then we can discuss any queries tomorrow. Have a great weekend. Thank you. Bye.
Bye.